Thanks everybody for attending today for our webinar. We're going to be, the topic today is GNSS integration, and we're going to look specifically at Trimble R1 and R2 receivers, GNSS receivers, and how they can work with GeoSync GO Plus. This is brand new functionality for us. This is something new and exciting for us to add for GeoSync GO, and really kind of moves us to another level. So very excited about it. Just as a little background review, GeoSync GO Cloud is a geospatial toolbox. So it provides a number of functions, a number of tools for use with mobile devices and for managing your data. The GNSS integration really fits into our overall passion, which is using this everyday technology, mobile devices for everyday work. Something we continue to pursue, and this is a big step for us in that direction. Integration with your GPS work into your daily integration with GPS technology into your everyday work is a big step forward. GeoSync GO Plus is the newest interface that we've put together for GeoSync GO. It's really a web-based system, and it's our primary central interface for the use of data and collecting data. So our focus will be GeoSync GO Plus. For integration is built into this particular interface. The other tool is GeoSync GO Mobile. It's primarily for disconnected use and does not work directly with the GNSS receivers. And GeoSync GO Desktop, which is really for data in terms of your form design, data dictionaries, and then the place you can go to export your data. But we're going to focus on GeoSync GO Plus and how it works with the GNSS receiver. GeoSync GO Plus, just a reminder of some of the features that are there. It provides a lot of capability beyond what we're going to look at today, and you can go back and look at some of the previous webinars to get a little better overview of what GeoSync GO Plus can do. It's a really powerful tool, particularly for sharing your data. So our topic, GNSS receivers, why we're interested. First of all, GNSS stands for Global Navigation Satellite System. So that's a pretty standard generic term. But what it really does is it refers to receivers that use not only the GPS system, which is the United States managed and deployed system, but also a lot of the other systems throughout the world. So it provides a much more robust solution because you have a lot more satellites and systems to be able to work with. Some of the things related to GNSS receivers that are important, particularly from GIS and mapping perspective, is we get the ability to have a real-time correction, so we can avoid some of the post-processing activities, so it can be more efficient. And then also, if we connect with Bluetooth, we have some ability now to integrate with phones and tablets, and that's what we do with GeoSync GO Plus. And of course, you do have a lot of satellite coverage because you've got access to all these different systems. So specifically, we're looking to Trimble R1 and R2 receivers. These are GNSS receivers, so they have access to all the different satellite systems. These receivers in an autonomous mode with no correction are still like about any other GPS. You're going to be around 3 meters with that. That's about the same accuracy as you're going to get with your phone with the built-in GPS that it has. So there, you don't get a lot of benefit in an autonomous mode with that. But the GNSS receivers have the capability, the R1, to be sub-meter, and the R2 actually can go sub-meter all the way to centimeter level, depending on the firmware that you purchase in the unit. Both of these units have Bluetooth, so they can be connected to Windows, Apple, or Android devices. And Trimble provides a status app that can be installed on any of those devices, which help with setting up the device and being able to monitor the status of that current connection. In order to get the accuracies that we really want to be able to get with these devices, we have to have some type of real-time correction. And the R1 and R2 offer a number of different options, but primarily the ones we're interested in. One is SBAS, or satellite-based augmentation system, which is always available. You can also use some internet connections, such as the virtual reference system in Kentucky. Particularly, that's a good option. VRS, and then RTX, which is Trimble satellite correction system that can also be added on to the unit. There's a subscription that can be purchased for use of RTX. The real-time corrections all provide, at least will provide in the sub-meter range on the accuracy. So when we're using a Trimble R1 R2 receiver, we are always going to be wanting to use some type of real-time correction in the field, because we're typically, for mapping and GIS, we're typically after at least a sub-meter position. Some of the real benefits with GeoSync GO Plus is you can pair these devices with iOS, Android, and Windows devices. And particularly, I point out that we can use that with a Windows tablet. You can think about a Surface tablet or some other type of Windows tablet. This can also be used with those devices as well. So we're looking at phones, tablets, and even laptops running a Windows device if you wanted to do that. GeoSync GO Plus with the R1, R2 are going to give you real-time correction, so there's no post-processing required. You can integrate this with your GIS data, so that means your GPS position that you're getting, that real-time position, can be overlaid over top of your maps in the field, your data. This integration also provides the ability to navigate to facilities to help recover existing facilities. And then GeoSync GO Plus also provides some ways for you to share your data with others. That is, you can create a web map or publish a web map and actually share the information with others, either in your organization or outside of your organization. If we look at the device here, this is just the R1 and R2. Some of the benefits here, key features, you get the same interface on all the different platforms. So it looks exactly the same. We're using GeoSync Go with the R1. We connect with Bluetooth, and then we can create customized forms to work with. So this is a look at the GeoSync Go Plus interface with the utility system. This is a pretty good shot of what the screen might look like on both the tablet on the left and then maybe a phone on the right. We have our utility locations, and then then the GPS is located on top of our data there, so we can see our current location. And again, since we're getting real time, we would be expecting that our GPS position is at least sub-meter. This is another shot of the interface. In this case, we're looking at sort of the navigation tools in GeoSync GO Plus, the ability to recover assets. So if we look at this, our GPS location is here, and if we imagine that these are our facilities. We're looking at control points here that we want to recover on site. These are important locations that have been mapped, maybe with surveyors have provided. We want to recover those. Then just by selecting one of these features on the screen, GeoSync GO Plus will give us a real-time update of our distance and direction of where we need to go to recover that facility or point. And because we're getting GPS positions in real time corrected, and they're less than a meter, could be less than a foot, then our ability to recover those is much enhanced from anything we've been able to do in the past. We also see over here on the left is we actually have an output, real-time output, telling us what the actual location the GPS is and what kind of horizontal accuracy that we're getting at any given time. Integration with the R1 and R2 also provides a way for us to capture data. So to capture information, we want to be able to enter data into a form. Traditionally, with the Trimble devices, we've used a lot what we call a data dictionary in the field. So this would be similar to that. We have a custom form that's been designed. This is for a construction site in a tabbed interface. Essentially, click on the GPS position, enter the data, and then we've captured a point at that location. So we look at what that might look like on a tablet and then on the phone. The forms are customizable, and you can also link photos and other documents to those features as you capture them. One of the other real benefits in GeoSync GO Plus is the fact that we can get this real-time update to the map. So what this illustrates is that we've mapped 2 locations here, and while we're in the field, we actually can see an update of the map. So as we map, anyone else that has access to that particular project can see the data in real time. As we're using GeoSync GO Plus with an R1 and we're collecting data, whatever those facilities may be, then if we had another crew in the field, then that crew could see what was being done by the other individuals, or even back at the office, we'd be able to get virtually real-time updates of the work that's being done without having to do any post-processing of that information. So we're going to drop out and actually make a connection to the R1 and kind of look at how that works. But before we do that, just a reminder of how we get into GeoSync GO Plus. If you install the app on your Android phone and you open the GeoSync GO Plus app, it's going to ask for a username and password. Once you sign in to that with the username and password that's been assigned to you, then you'll have a list of projects. You select the project, and then the map will open, and then you're ready to go. So this is the basic process of being able to sign in on any of the devices or to be able to open up and get to your project. Once you get the map open, you can go to the menu, and then you can begin to make your connection to the R1 and start using it in the field for mapping data capture purposes. So I'm going to drop out here to look at tablets. So what I've got on the screen now is this is a Windows tablet. And so what we're going to do then is we're going to look at connecting to our R1 device. And the first thing we would do is we would have the app from, this is the Trimble app, GNSS status. This app needs to be installed, which provides the ability to change settings on the hardware itself, and also we can kind of monitor what's going on with the R1 or R2 device. So as we look at this right now, this is already connected to my device. If I wanted to connect to other devices or switch connection, I can click on this and it'll give me a list of devices that are connected through Bluetooth. So what we're doing is we have the R1, which is Bluetooth enabled, and then we've paired that device with our tablet, and then we'd have a list of whatever devices are currently active, and we can switch between those. Right now I'm connected to my R1, and you'll notice here the accuracy that I'm getting right now is 2.6 meters, and this is telling me that I'm tracking 18 satellites at the moment. Actually, that's 18, 19 in that. But 2.7 meters is really not where we want to be if we're doing mapping. So what we're doing right now, this is an autonomous position. We're not getting any kind of real-time correction. So what the GNSS status app does is it lets us set up our connection. I'm going to go to my real-time correction settings, and you'll notice here the primary source is set to uncorrected. I'm going to change this, and we're going to look at SBAS, which is Satellite-Based Augmentation System. I'm going to change that to SBAS and save, and that's going to update my device and tell it that I want to use this type of real-time connection. Now I'm going to go back to my home screen. We'll give this just a minute, and we should see the position really improve. While that's updating itself, I'm going to go here to the GNSS status screen, or the detailed status, and this always gives us a lot of information related to what's going on with the R1. When we come to here, we get a list of all of the satellites by system. We can see the different GNSS systems that this is tracking and how many satellites and how many are in use. And then we also can look at our real-time connection that's going on here. I'm going to go back to the home screen, and we'll notice now that this is telling me that SBAS is my current real-time connection, and this is giving me an estimated accuracy of about 54 centimeters. So now we've gone from several meters in accuracy, about 3 meters in accuracy. Now we're down to about a half meter in accuracy is what it's projecting that we would get as we're mapping. Now we're pretty good to go. What we want to do now, now that we're connected and we know we've got we've got the R1 configured properly, then we're ready with the GeoSync GO Plus app to be able to do some mapping. So I've already opened this and signed in. I'm going to open my project up, and so I have a map. In this particular case, my map's opened up. I have a street map, and I think these are all survey monuments. You might have your GIS data available, whatever you need to do the work in the field. But what we want to do is we want to make a connection here to this Bluetooth device. So we go to Location menu, and we have a Bluetooth option. And then from here, this is going to go out and look for Bluetooth devices that are connected to our device or paired with our device. On the Windows device, it takes a few seconds for it to actually find and discover those devices. I'm going to turn on the GNSS capability for GeoSync GO Plus and select the device that I want to use. And then if we want to connect, then we just turn on GPS, and this is going to connect GeoSync GO Plus to the R1. And now we're connected, and we can see that it zooms us into the GPS position, and we can see that the blue dot that's turning on and off is actually our GPS location. And we're here in relation to a number of our control monuments. We'll move the menu back, and then we can see a real-time update of what's going on. So we have the status. We don't have to go back to the GNSS status app to see what's going on. So within GeoSync GO Plus, we can see the type of correction, which is SBAS. We can see how many satellites we're tracking, and this gives us the estimated horizontal and vertical accuracy. This is in meters. Both of these displays are showing meters. So we're showing about a half meter is what the projected horizontal accuracy is currently. In order to be able to use this to collect data, it's pretty simple. We just select the GPS, we tap on that marker, select it. Once we do that, we can go to our data dictionary list or our workflow list form. We pick the form we want to use, such as if we wanted to do a GPS gas marker, we can open that up, type in let's do a different, let's do a gas valve. This was a gas valve. We could enter the size of that valve, 3-inch, turns 15, comment is, and then we could link a photo to that if we wanted to do so. In the form itself, we have the GNSS info that's going to be tagged to this particular feature once it's mapped. So the information, the real-time information, is always tagged to each feature, which tells me what was the estimated horizontal, vertical accuracy, what type of correction am I using, and what is the height above ellipsoid, or the altitude that it's currently recording. So once I've filled out my form, then I can click Save, and that feature has now been mapped. I'm not sure whether that valve layer is turned on, so I'm going to go in here and let's see if we have. Okay, I don't have the valves in my list, so let's do a different feature here, just so we can get one that will show up. I'm going to turn on. I'm going to do a GPS test point. Give this feature name as gas valve, and then we'll save. And we'll give that a second to update. While we're doing this, we also have the ability, if we wanted to change our background, we could turn this on and use a aerial map background. And you'll notice that the point that I mapped is now turned on the screen, so I've got a real-time update of that location. So it's updated. That's my gas valve, and whatever symbols I've set up for that as I map, I would be able to see those points show up, and then anyone else that has access to that map can see the real-time update if you wanted them to do so. I'm going to go back to my layer listing here and turn off GPS point for just a minute. And then I want to look at the ability to use this for navigation purposes. So another application for this would be to recover these points that are out in this parking lot. And if I select any one of these points, this will immediately go into navigation mode, and it will give me an immediate readout of what the distance is to that particular location. After this demo, my GPS is fixed at that location, but in actual application, as we move closer to this particular point, then the distance will update in real time until we can recover that particular point. And if we select on any one of these other points, it will immediately begin to try to navigate us towards that particular location. Not only that, if we wanted to discover a location, if we set a user point here on the screen, then it will also navigate to that location and give us a distance. So we could use this also for measuring on the map. As an example, if we wanted to know how far is it from this location out to say the edge of this lake or pond on this side, just by setting a user point there, it's going to tell me that's 442.5 feet. Whenever I select the GPS marker and ID that, then I have access to all the statistics associated with that. And then also, one of the other items that GeoSync GO Plus does is, if you are in Kentucky in an area where the Kentucky from above LiDAR has been completed, this will do an estimate of the elevation from the 5-foot DIM that's hosted by the Kentucky GIS Division of GIS on the state level. In this case, it's estimating that the elevation at that location is 1,002.5 feet. And that's just another benefit if you're using this particularly in Kentucky. So let's go back and look at our location information. And again, we're seeing the different real-time readout from here. If we go back to our status, GPS status app, and I'm going to go back to my real-time configuration, and I'm going to make a change here to, this is where we could change this to our VRS connection. And I'm going to go ahead and change that. And at this point, we should now have uncorrected positions, and it'll take it a minute, but then it will switch over and we'll be able to have what we have now is the N-trip connection or our VRS connection. And if we come back to GeoSync GO Plus, we'll notice here, and for now this says engine type none, but this will should say N-trip, and the type of correction though is still code. And then we're seeing our horizontal and vertical accuracy. So now we're actually collecting data using the VRS as a real-time connection, real-time correction tool. That's a pretty good tour of how you use the R1 and R2 with GeoSync GO Plus. It's a very productive tool. It can be used to pair your GIS mapping with your field collection. Just remember also that the GeoSync GO Cloud has a number of good tools to help you integrate the data directly back into your ArcGIS feature classes, and then to be able to publish that information and share it. Thanks for attending our webinar today.